for the introduction. Hi, everyone. Well, first of all, thank you for the introduction, Hubert. Like Hubert said, I'm Eric. I work at GOG.com. I'm actually a engineering manager now, so I'm in a people role, not so much technical, but this has been a very nice opportunity to remind myself my roots, which were as a front-end developer at GOG.com as well, and hopefully I haven't lost the touch. So as you can see on my slide, I'm going to be talking about desktop applications and specifically about multi-app window desktop applications using front-end technologies. And if there's one thing I want you to take away from this presentation, I would like you to think about the benefits of using multi-window, of creating multi-window applications when you're building on desktop. And then I'm also going to be introducing sort of a technique that helped us build GOG Galaxy application, which is a multi-window application. And I can maybe recommend or suggest that you use this technique to make this process easier for you. So let me switch slides. This is the structure of my talk. I'm going to start off with an introduction, story time with GOG Galaxy, basically the motivation for how we got here and why I'm actually presenting to you. And then I'm going to talk about the technical details of this technique that we developed, specifically how to connect the parent and child window front-end frameworks. And of course, with anything, there's trade-offs. And then if there's time permitting, meaning if I'm speaking very, very quickly, we can have a closer look at the code. And then at the end, I will share links to GitHub and even to an NPM module that you can check out for yourself and try out what I've been talking. So fear not, you can, at the very end, you'll see links there that you can then clone the repos and get started by yourself. So starting off with an introduction to the desktop frameworks. So there are several frameworks for creating cross-platform applications using JavaScript, HTML, and CSS. We talked about Electron at the beginning. This is by far the most popular one. What a little history about this is it's currently maintained and developed by GitHub, and it was created by GitHub as well, but originally it was created actually to power an IDE, not the one we're probably all thinking of now, but one called Atom. And it was originally called Atom Shell. Eventually, I think Atom fell to the wayside. VS Code became more popular. But the concept of Electron, the rebranding of this idea from Atom Shell to Electron, stuck around and has become extremely popular. It's by no means the only one, though. Some of you maybe have heard of these other frameworks. NWJS, formerly Node WebKit, is very similar in functionality. And Neutralino. This is one other one, which is full front-end technologies, including accessing native APIs also in JavaScript. And the main difference between Neutralino and Electron is Neutralino doesn't package an entire Chromium browser in the application. It uses the default operating system one available, depending on platform, of course. That will be different. So basically, all of these frameworks, they operate under the same principles. They have a web browser. For the ones I just mentioned, that's either Chromium or native WebView. And then they define a JavaScript API bridge for accessing platform features like file system access and everything else that you would be able to access if you were using the native APIs directly, usually in C++ or some other languages, depending on the platform. But the list doesn't stop here. The ones on the left those are the full front-end technology frameworks, meaning everything in JavaScript, HTML, CSS. But it's not the only framework that allows you to define the front end of your application using web technologies. So I did a search. I didn't do an exhaustive search. I'm not pretending that this is all there is out there. But my search came up with some other frameworks that you may have not heard about, or maybe you have. One is Tauri. I think it's trying to occupy the same space as Neutralino in that it's attempting to be extremely lightweight. The only difference is that the application, the desktop backend, meaning the place where you interface directly with the platform, is Rust. Although they do also offer a JavaScript API bridge as well. There's another one that I'm familiar with called CEF, which has a C++ backend. I say I'm familiar with it because this is what we use to power GOG Galaxy, an application that I learned about all of this while developing. And then there's also Qt. With Qt Web View, you can build applications like this as well, also C++. And of course, my disclaimer, I might not know everything out there, so this is not a comprehensive list. If you know about something that's really interesting or cool, I'd actually be really interested to hear about it. And please let me know at the end in the questions or some other way about any other ones that I missed. So, as we hinted in the introduction, these types of apps are actually very popular, meaning there are some very popular apps that actually use Electron, and you might not know about them. So let's dive into that. This is the list that I decided to show because these are the ones that are, let's say, most important for me. If you're a front-end developer, I would probably guess that most of you use VS Code. Slack, this is the communicator of choice at my company, especially since the pandemic. We've been using this more than ever. WhatsApp is obviously very popular. And then of course, Twitch and Discord and Microsoft Teams and Figma. Figma, if you're a designer, probably you're very familiar with this one. And Skype, if you remember, like 10 years ago, when that was important. But of course, those are just those that are using Electron. From my experience, there's some other notable apps. Spotify uses CEF. You may not know that, but actually I'm pretty sure they're the ones that are, the company is responsible for pushing out new versions. So they sort of own, they claim ownership of this framework. The second application icon, this is GOG Galaxy. This is an application that I learned all of this on. We also use CEF. And more recently, Cyberpunk 2077 was released on many platforms. On GOG, we use GOG Galaxy, but if you bought it on Steam or Epic, it would have come bundled with what's called the Red Launcher, which is a launcher for CDP Red games, and we use Qt Web View in this one. So when I was looking at what Electron apps there are out there, and especially which ones are extremely popular, something really, really weird occurred to me, which is that except for Microsoft Teams, they're doing this well, in my opinion, none of the apps actually use multiple application windows. And I'm asking myself why. So this leads me then to give a short introduction to some aspects of desktop design principles. And I was reading through the Microsoft docs because Windows, the most common desktop environment. Mac OS I was also exploring, but the Microsoft docs, I've quoted one sentence here, and I'll just read it out loud because I think it's very important. Help your users be more productive by letting them view independent parts of your app in separate windows. On Mac OS, I didn't find a statement quite like that, but reading the documentation and also just exploring macOS native apps, it's clear that this philosophy is also very important. So this is the Mail app on macOS. All the examples and screenshots I'm about to show you are going to be on macOS because that's the system I'm using. Here, it lets you view separate messages and composition window in separate windows so that I could drag, for example, to a separate screen or view them side by side, or basically however I want to arrange it, I can do that. Messages app. This is literally iMessage. Same thing. I can right click on a person and pop it out into a separate window to position as how I see fit. And since this is a developer conference, or not only, but all of us here have a technical background, this is Xcode, a native IDE. This is probably for me my biggest pet peeve. I use VS Code when I'm coding. In general, I very like it, except I am unable to open a file in a separate window, to put on my left monitor, for example, or position however I want. They try to address this issue by, I think it was relatively recently, they introduced split view, or maybe that was Slack that introduced split view. But it's clear to me that as updates are coming to these applications, they're trying to address this need of users to be able to view separate information at the same time, but they're constraining themselves into one application window. And so they have, open on the right pane or split view or something like this. And I'm just thinking, why not just use a separate application window and let the user position it what works best for them. So this is just, those examples just show me that messaging apps on desktop should allow users to open in separate windows. IDEs on desktop should allow users to open files or other information in separate windows. But those apps that I mentioned before, they don't, except for Microsoft Teams. Kudos. So why are so many Electron apps not using multiple windows? And I don't know the definitive answer. I didn't survey anyone, but I have some suspicions. I'll share them with you now. So one of the great things about Electron is that it allows web developers to build on the desktop. And I suspect that there's a lot of web developers who are bringing web design principles over and just not thinking twice about that. On desktop, there's no pop-up blockers. There's no taboo against using multiple windows. But as web developers, maybe we forget that. Another big one that we in GOG faced when we were building GOG Galaxy is that actually the front-end frameworks that are available, they're not designed for creating multiple windows. In fact, they're designed for creating single-page applications, quite the opposite. So this actually makes it more difficult to achieve what I'm talking about. And I also suspect that there's some cases out there where the web app was created first and then the Electron application was simply a wrapper. So basically the effort wasn't put in to make it more desktop friendly. So story time. Building GOG Galaxy with multiple windows. So I'm gonna just show what GOG Galaxy can look like now. Obviously, this is not how you use multiple windows to its best example, but I wanted to show what we wanted to be able to achieve with GOG Galaxy. So we wanted GOG Galaxy to be a place where you can store and manage your collection of games. And we wanted it also to appeal to the power user, those who want to edit metadata, who want to customize their experience, their view, their library. And so we knew that we wanted to allow users to change all this information, the title, the rating, and so on. And we also knew that we wanted the experience to be almost as indistinguishable from a real, when I say real desktop application, I'm talking about using native desktop frameworks. So we wanted to use those design principles that are best practices for desktop, which is separate information, separate views in separate windows. So this was our requirements, this was our goal. And the question was, how do we actually do that when we're using a front-end framework? In this case, we were using Angular. How do we use this framework to achieve what we want to do? So first of all, there's several challenges that we immediately identified. First of all, with the application that we wanted to build, there's essentially unlimited application windows. You can have thousands and thousands of games in your library. Each one, you can open the edit window. You can open a separate configure window, which lets you configure command line parameters for the game when you want to launch it, etc. Furthermore, the way our application data flow was constructed, the data can be updated from many different places. So all the data is cached locally in a database, but if you have a fresh install, it will pull that data from the backend and populate and hydrate your database so that your application, you can have your same application on many windows. And furthermore, we wanted to allow users to edit metadata, so either sorting title or rating of a game, and this data can be visible in multiple windows. For example, if you have the main window showing Cyberpunk, for example. I can also edit the name and see the name in the main window, but edit it and see the name in the child window. So this data is visible in multiple places. So when you're thinking about having multiple windows and communicating between them, as a web developer, your first, let's say, naive thought is to reach for the canonical way of communicating between windows in browsers, which is using post message. This is probably the recommended way. It really supports separating concerns. It supports sandboxed applications, etc. But when we thought about this potential avenue, we realized that for all of the data and all the actions that we want to do in the child windows of our application, we would need to define a post message interface for all of those actions. And in general, with basically unlimited windows, we felt like we would be running into scalability problems. Like every single time we wanted to add something, we'd have to code the interface. We'd have to do work every single time. Of course, you can try to abstract some of the ideas out and define a single interface, but ultimately we still had to go through this post message interface. When we have this, it implies that we would need to have in memory the data and even the logic in both the main window and the child window. This is because if we want to show the data, we have to have it somewhere in some model somewhere. And this led to also another thing, which was multiple sources of truth. And especially when we're talking about having the data be updatable from, let's say, the backend servers or from the local database, this made it challenging to think about how we would do this properly. And then furthermore, if we're thinking about adjusting or modifying and iterating on the application and releasing new versions, basically any application code, any change in application code would require related changes in the interface, in a child window code, and we felt that this was just also a lot of work. The last thing that I didn't list here in the bullets, but actually on top of all this, we had a very ambitious project and we had also an ambitious deadline. So we felt like we couldn't spend a lot of time just creating boilerplate. We wanted something a little faster, a little easier to develop with so that we could iterate faster and move faster. So then we came up with an idea of how to actually connect directly the parent window Angular framework in this case, and the child window Angular framework. And the key insight for this was realizing that through the window.opener property in the child window. So this is the property that gives you a reference to the global window object in the main window of the opener window. We could access the parent window's global state. And not only that, we could probably figure out how to synchronize the view updates between the parent windows and the child windows. And with those two key insights, we realized that we could, by doing this, if we could get access to the global state and we could also synchronize the view updates, this would essentially allow the two frameworks operating, one in the main window and one in the child window, to behave as if they were one framework. So GOG Galaxy, we're building with Angular. So now I'm going to dive a little bit into how we actually achieved this with Angular. So the first part we identified as being, important was we needed to access the parent window's global state. So for those of you who aren't familiar, the canonical way of storing state in Angular is using global singleton services. And these are injected. This is the way Angular works. And what this implies for us is that in order to access the parent window's global state, what this really means is that we need access to the parent window's injector from the parent window's framework. And here, I'm just this is very simplified. I've cut out a lot of details, but I just wanted to show you how we ended up doing this. So here we have an Angular module. What's key to remember is where any piece of code is being executed, in which context. So in this case, it will be executed in the parent window or the main window. I use those terms interchangeably. In general, what's important is we get a reference to the injector using just Angular's dependency injection system, and then we just attach it to the global object. You can choose the string at random. I chose this name because I ended up naming an NPM package this, so it seemed to make sense. So basically, we get a reference to the parent Windows injector, and we attach it to the global object. Next, in the child window, we just get a reference to this. Through window.opener, we get that injector. So now we have the JavaScript object that is the parent Windows injector. So how do we actually integrate that with the child Windows Angular framework? Well, luckily, Angular provides a way to define providers. And basically all we do is we just enumerate all the services from the parent window that we want to access in the child window, and we define a provider object like this. So for every injection token that we would like, we would provide and basically redirect this request for this service and just make sure we get it from the parent window. And it's literally that simple. So doing this, we have access in child windows to the instances of the services from the parent windows. So the next important part is, of course, making sure that the view updates in the proper way. In Angular, view updates, also known as change detection in most frameworks, this is controlled by Zone.js and specifically the Angular's wrapper of this library. They hook into certain events. For those who don't know, Zone.js is a very interesting library where it provides the way to have sort of an execution context across asynchronous calls. So basically you can store state and keep this state in memory across set timeouts, promises, and all these asynchronous event handlers like click handlers. You can actually keep contextual information across these events and you don't lose them. And Angular hooks into this so that it can trigger change detection whenever a set timeout fires, because in general, a user might change the view in the callback for a set timeout, or same with a promise, or same with a click. So it hooks into these events using Zone.js and triggers change detection. So when we think about our application, a parent window, a main window, what is it that we actually need to do? Well, first of all, if we're accessing the main window's global state, which can in turn change, or probably it does change what we show to the screen, basically what this means is that every time the global state in the main window changes, we would want to also update the child window, because in general, there might be something new to show. So the way we approach this is actually we basically want to trigger change detection in the child window whenever change detection happens in the parent window. But of course, if we have access to the main window's global state in the child window, we can just as easily change that state from the child window. We could click a button, cause something to change. And in this case, we also want to change the main window because that might trigger a change in the main window, which was originating from the child window. So we actually want to do, we want to trigger change detection in the main window, in the parent window, also whenever it happens in the child window. So we actually want to trigger change detection both ways. So this is some pseudocode basically describing how we did that. Using the method I sort of described a few minutes ago, we actually get the reference to the parent Windows ngZone. And I described that this is the service that can control when, or can tell us when change detection occurs. And since this is the parent Windows ngZone, this service will actually allow us to know when the main Windows change detection runs. And we also want to get in the child window just a reference to the change detector. And this way we can just manually trigger change detection. So how does ngZone, or how does ngZone tell us when change detection happens? Well, if you dig into the documentation and you read a bit, you'll discover actually that change detection will happen whenever this event fires. The on microtask empty observable will emit an event. At this point, I don't remember if it emits after or before change detection happens, but every time change detection will happen, it will trigger this event. And we simply subscribe to this observable, and we manually trigger change detection in the child window. So this is updating the child window whenever change detection happens in the main window. And now we need to go the other direction. We also want to trigger change detection in the main window, also known as the parent window. Sorry that I'm switching terminology. Whenever the child window triggers change detection. And we do something very similar, except we will actually get two versions of ng-zone. First, in the child window, we'll get access to the parent window's ng-zone using the method I described minutes ago. And we'll also get the local child window's version of ng-zone. Because remember, there's two Angular application runtimes, one for each window. And this time we, again, react to the on microtask empty observable. And every time this happens, we actually manually push something to run on the parent window's ng-zone. And this running, in this case, it's a no operation function callback, but just running something on the ng-zone will again trigger the on microtask empty queue. And this is important to do here because if we don't, and imagine we have 3 child windows and 1 parent window, if we only trigger the view update in the main window properly, that view update won't then propagate to the other child windows. By actually running a no-op inside the parent window's ng-zone, we can actually propagate this change to all other child windows. Again, this is a very high-level overview of how this is done. A lot of the details, nitty-gritties are hidden. If we have time later, we can look into them. But I wanted to make sure that we saw the essence, the core of what's happening. So at this point, I built a demo app using this, and I'd like to show it, if I can. So here, this is an app I've built. I've created a service called Counter. If you've ever bootstrapped apps before, I think the Counter is a very typical example for how to show you how it works. So it should hopefully be familiar to a lot of you. You can increment it, you can add 3, you can reset it. But of course, I have also built a child window. And it's very similar, except it's a separate app running a separate instance of Angular. The only difference, the biggest difference, of course, is that inside of the child window app, we're not instantiating a new instance of the counter service. We're actually getting a reference to the parent window's counter service. So we can see that this is happening by incrementing the count, adding 3, resetting. And of course, I mentioned, I've been talking a lot about main window and parent window. This idea doesn't just stop at one main window though. Sorry, at one parent window, one child window. We can have as many windows open, and it will synchronize the state and also update the view automatically across all of them. So you can imagine how this makes app development, especially with multiple windows, very fast and very easy, because you don't have to start thinking about the interfaces for example, post messages, etc. Okay, let's go back. So now I want to talk about the technical details of React and React Redux. At GOG, we did everything in Angular. This is the framework we're choosing to focus our expertise on. But I'm very well aware that Angular is not the most popular framework, and a lot of people try to stay away as much as possible. For the sake of this talk, I thought, how can I take this idea of connecting parent window and child window frameworks and bring it over to a different framework? And I decided to do this for React with React Redux for the global state. And it turned out to actually work very, very well, and in some ways much more easily than with Angular. So let's have a look. So first of all, we want to access the parent window's global state. With Redux, sort of by definition, the Redux store is that global state. That's how the whole concept is defined. And so basically what we need to do from the child window is access the parent window's Redux store if we want to have a shared global state. And this is the pseudocode for that. We get the Redux store from the parent window, and we just attach it to the global object so that we can later, in the child window, get a reference to it using window.opener again. And when we're talking about specifically React Redux, the way that you provide the state is you give it to the provider element here, and that's all we do. And you bootstrap the rest of your app the way you normally do, the way you always do. Very easy so far. So next part is synchronizing the view updates between your parent React app and your child window React app. So in general, updating the view in, let's say, vanilla React, meaning without using Redux, you use setState. And this function means that the need to change the view is set by the developer. The developer determines when it happens, and he does so manually every time we're calling setState. Well, however, when you use React Redux, the library React Redux hooks into this and sort of does this automatically with you. And actually, the nice thing that comes out of this is that when we look at the pseudocode here, and we give the parent's Redux store to this library React Redux, the views are just updated automatically in both directions. So this was done easy, very, very nice actually for that. So let's have a live demo of that. So here we see, oh, I was playing around with it before. I'm just making sure it works. Here we see basically the exact same app, except this time the counter is in the Redux store. It's not a service with an observable. So basically same functionality, different way of storing the state. You can increment, you can add, and now let's just open the window. Oops, I opened in a tab. Let me shift click. And let's just right away open another one. And here we can see that it works just out of the box like before. If I click on the rightmost child window, it works. Reset, add 3. It basically just works out of the box really nicely. So now the question is, I've figured out how to do it for Angular and React for the sake of this talk, but what about other frameworks? So I haven't taken the time to get familiar with the other frameworks that are out there, especially the popular ones, Vue.js or Svelte. But I see that with an understanding of how a framework manages global state and how this framework triggers change detection, maybe you too can use this idea of using window.opener to connect the parent and child frameworks, and maybe you can implement this idea for other frameworks as well. And again, if you do this, I'd be very interested to see, because I mean, for me, this is just a very interesting way of looking at JavaScript frameworks and pulling back sort of the mystery of the black box and that is usually these front-end frameworks. But of course, there's nothing free in life, and building an app using this technique, it does come with some trade-offs. And I'd like to just share with you some that we have discovered or are aware of when we are building GOG Galaxy. So the first, maybe this would be obvious for everyone, is first of all, this way of building apps and building multi-page desktop applications. This is not obvious. Nobody coming into your team will have known that this exists unless they see this talk later, of course. And you're probably going to have to explain to them the philosophy and the way that this works before they can start being productive. So it's just one more step into onboarding someone. The second one that is worth keeping in mind is that this totally breaks encapsulation. By accessing global state from the main parent window, you are logically entangling the apps And when I say the apps, I'm talking about the, the instances of your front-end app in the main window and the child window. And even though the source files might be different, logically, they are behaving as one app. If you ever decide later to take some part of, let's say, a child window app and create a module out of it, you're going to have a hard time because it's going to be intimately connected with the main window. With the case of GOG Galaxy, where we're building, this is in fact the way the app works. It's basically every child window is simply an aspect of the main application. So in this case, it doesn't actually cause us any pain because we're never going to be trying to take logic out of a child window and use it somewhere else in a completely different context. One other thing that maybe some of you have already thought ahead about, which is that this makes unit testing difficult. All of your code, or at least the code in the child window that uses global state from the main window, is trying to access the main window using window.opener. Test environments are usually, a Chromium browser, or maybe use headless Chrome to run it without popping up in front of your eyes. This environment does not have that parent-child window relationship. So you have to do some hacks. You have to be creative with changing your app so that it works and is able to be tested in a unit test way, meaning in isolation. So you have to be mocking all of the dependencies that are from the main window. And you have to make sure that you don't try to access window.opener because you're immediately during test bootstrap, you're going to be getting an error. The fourth point, this is one that hit us a few times. You have to be beware of memory leaks. In general, you should always be beware of memory leaks. Every time you subscribe to an observable or you set up some sort of event handler, you should clean up after yourself when you're destroying components that use that. Normally, though, if you don't clean up after yourself, you might be keeping in memory the context of a function, maybe a little bit of local data. If you forget to do it in a child window, it actually keeps a reference to the entire window object alive. The garbage collector can't say for sure that this is not needed anymore and collect, the child window's window object. And with that implies also it can't garbage collect the Angular application or the React application and everything else. So every memory leak is going to come back and hit you not even twice as hard, 10 times as hard. So you have to be very careful of that, not to massively hemorrhage memory if you're not careful with how you clean up your resources after you close the child window. And one last thing to note is that actually not every desktop framework will support window.opener. What's implied by using window.opener is that actually the main window and the child window are running on the same process. If they're running in different render processes, there is no way to simply access the JavaScript context from the main window. They're in a different process. This is just not available. I know for Electron and NWJS, it's possible to set it up so that whenever you open a new window, it's in the same renderer process. But I was looking in the documentation of Towery.js, which is one of the other frameworks, and they said at this time, you can only create a new window in a separate process. So this would not work if you decide to use Towery.js. So basically, just make sure that you can open new windows in the way that supports this technique that I've shared with you. So let's have a look at the time. Okay, we have some time. So I'd like to now take a closer look at actually the code that I used to build the demo. And let's start with maybe the React code, because I know that Angular has limited appeal. No matter what, you can look later at the demo's GitHub pages and look for yourself too. So you're not going to be lost with it if we don't get to it right now. So let's move the, so this is the NGX one. Okay. So before I look at the code that I sort of showed the pseudocode for, let's first of all make the font bigger. Let's close this. So the first challenge you're probably going to have when trying to set up a multiple window app using a front-end technology is that the framework just doesn't support this very well. And not only that, well, basically what this means is most frameworks, they sort of hide the Webpack configuration, or they hide the rollup configuration. So you kind of have to find a way to dig in there and modify it yourself. And that's not always easy, but I did the hard work for you. So let's look. For the React app, I just followed a tutorial to set up a React using the Vite bundler. And it uses rollup under the hood. And it was quite easy. And in general, normally this would just be empty. You would not define this, but you would just use the React plugin for Vite. But if you want a multiple window application, what you need to do is add to the rollup options, which basically add additional config to the underlying rollup config, is define more input files. So these are basically entry points. So you have your standard one, which is index HTML. If you don't even define this, this is going to be defined by you by Vite. And for each additional window, each additional child window, you will want to define one more line here and give a path to that HTML file. So let's go over in the sidebar and click the main window. So this is what is automatically bootstrapped for you. This is your index HTML that you've probably seen a million times. And you have the reference to the main window JavaScript or TSX in this case. But of course, there's the child window as well. And it's basically the same, except you reference a different JavaScript. And let's have a look now at the actually, maybe I make everything bigger. There's our tree. We're in the source file. This is probably not a typical folder structure that I would recommend for any sort of application that you're wanting to build at scale, but for the purposes of demonstration, this was the easiest. I have all the code related to the main window in the main window folder, child window. Then I have Redux code, so the store and the reducers, etc. here. And then I have one file for parent Redux. So let's first look at the main window. Okay, too big. Basically, in the main window, this is probably nothing new for any of you. You grab the actions from the store, and you hook them into the view. So you have increment, you dispatch the increment action, add 3, you dispense the add 3 action, reset, and so on. And also I've added a button for opening the child window, of course. And you notice here that all it is does window.open and target blank. So again, nothing mysterious there. Now, the child window basically is exactly the same. In fact, I think it's more or less the same, except I changed some text to say child window instead of main window. So let's actually go now to the child window.tsx. So here, this is where we bootstrap our React app and pass in the child window component. And here you see exactly this line. You get the parent window store and you pass it into the provider here. So let's have a quick look at the parent window store. And I defined 2 functions. There's some TypeScript so that the TypeScript autocomplete will work. And then I have one function to expose the Redux store. This I will call in the main window, and I'll see that in a second. And all that does is it takes the store and attaches it to window.parentRedux, and that's this line here. And then the get parent Redux store. All it does is basically returns window.opener.parentRedux. I have some checks here that if you're running it and it doesn't find it, it'll let you know about that. But that's basically all there is. And in the main window, TSX, I simply expose the Redux store by calling it first. And that's literally all that's needed to connect and bootstrap this app. Okay. I'm not going to go into the Angular as much because it's, as you saw from the pseudocode, it's a little more involved than the React one. And we're almost at 45 minutes. So I want to just show this slide for everyone. All the code for What I showed you is available on GitHub. I'll leave that up there for those who are interested. Details about how to change in Angular, it uses Webpack under the hood. I've described in the README what's important to change in the Webpack config. You'll have to use a Webpack plugin that allows you to add additional configs there. It's basically, you can use this demo as a boilerplate, and all the details are in the README. And also because the code needed to get it working for Angular is a little more involved, I also published an NPM package, which you can see at the bottom. And I just want to summarize again. I went really into details about the technique of how this technique works. But really, that's not the point I really want you to take away from it. The point I want you to take away from it is when you're building for desktop, use multiple app windows when it makes sense. When you have separate parts of your application, separate views that you can see by yourself, allow the user to do that. Allow the IDE to create a new window so you can drag it to your other monitor and have it full screen. Allow your chat app to have your favorite chat open all the time and always visible without having to click the back button. And basically, next time you build a desktop app, consider using these techniques that I've showed you here to speed up this development and to make it a lot less painful. And with that, I'd like to thank you for attention, and we can go back to the studio.